Hello, and thank you so much for your interest and time for our presentation. I am Dr. Joby Hilliker. I'm a professor at Westchester University, which is located just outside of Philadelphia. I'm in the Department of Earth and Space Sciences. I've been there for over 15 years now, and I have my cousin and my colleague, Dr. Shannon Hilliker, and we are going to present to you a research project-based learning, PBL, in meteorology using the SPC Online Severe Weather Events Archive. And I'm going to now turn it over to Shannon.
Hello, everyone, and welcome to our presentation. I'm going to do the first part and first just do a quick review of PBLs. So in problem-based learning projects, students work collaboratively to answer open-ended questions that their instructor gives them in a series of steps that leads them to acquiring new knowledge associated with their course content. And so the second part, PBLs and meteorology. Meteorology is one branch of science that lends itself well to PBLs in the classroom. And why is that? That's because in meteorology class, there's value in infusing current cases into the curriculum. Having students do some sort of data collection and the use of data collection in online cases supports 21st century skills such as computer literacy and technology use. And then there's this added bonus nowadays with the times we're in and the global pandemic that this can still be used with distance and virtual classrooms, which is a consideration as well. The use of PBLs in meteorology education has been limited in the literature, but there's one I want to highlight from 2015 where the authors shared a PBL with emergency workers to plan for severe weather. This one has similar real-world application in that students get experience with prediction on severe weather and the ingredients that make severe weather. And so the purpose of our presentation is to offer practitioners an additional option that has been conducted by the authors because Joby has been doing it for over a decade in his meteorology course. So the third part, this PBL specifically has students working together in weekly activities to collect and analyze data for severe weather using the Storm Prediction Center, and that is responsible for monitoring severe weather across the United States. So the students working together with technology, and you can use more or less technology depending on what's available and how distant your students are. They use their interpersonal skills to negotiate data collection. And then at the end of the semester, the students construct an oral presentation along with a written manuscript that reveals frequently occurring weather, severe weather atmospheric ingredients with threshold values. And some examples of those are tornado, hail, and wind. And students are also asked to modify those threshold values that may differ with respect to the severe weather type. And as students work through this series of activities, it should become evident to them that there are favorable parameters, but also that they can vary. And so students are challenged to provide a hypothesis as to the cause of severe weather. And so now I'm going to turn it over to Joby, and he's going to talk to you about the activities specifically.
Very good. Thank you, Shannon. And I just want to say this particular PBL is appropriate for a second semester meteorology course. Students do have to have prerequisite knowledge such as the jet stream, atmospheric stability, LI, mid-latitude cyclone, how to read a 300 millibar map. You're more than welcome to incorporate this for meteorology majors. I think this will be really awesome in a severe weather and/or forecasting class. Now, in terms of the implementation, I actually have a picture of a couple of former students, and I like to divvy up the class in pairs. It just makes the workload for me and also the students a little bit more manageable. And what you want to do is assign each pair a different year of study. And this database, as you might know, goes all the way back to 2000, so that's generally not too much of an issue. So each pair gets a different year of study, and basically that's their baby. That is their year. And what's really awesome is at the end, when we do these oral presentations, it kind of all comes together where you will see time and time again these favorable or common ingredients for severe weather. Now, as Shannon alluded to, I do have 5 activities which I disseminate throughout the semester. I typically do this in the lab portion of my class, and the lecture portion I reserve for the actual new material, such as what is positive vorticity advection, what is warm air advection. And just because of limitations, both in terms of space and time, I don't have time to go through every activity. You're more than welcome to email me or Shannon if you want to see the activities. This PBL, by the way, will be published in the Journal of College Science Teaching in 2021. Very briefly though, the first activity, students will identify the top 5 severe weather cases for their particular year and for their local region. So we choose, of course, Southeast PA being in Westchester. And then students will go to the SPC website and look at the surface data, take a look at the upper air data, and then take a look at the radiosonde data. What they'll do is they will go through the data collection and data analysis phase. And I've just given you a sampling of what one of the activities, which is going to be a data table or artifact, that the students will complete. So students will look at the maps and they will identify for these both quantitative and qualitative variables what actually happened prior to the severe weather event. So for example, here in Pennsylvania, May 19th, 2019 was a pretty significant event. And we had dew points around 73. So that gets checked because the dew point was greater than 65, which is what you typically would need for severe weather. And then finally, the last activity, number 5, we put it all together, we synthesize the data collection, they go back to what they collected, and basically they determine the percentage of the 5 cases that were shaded or that had each of the favorable parameters. And just as an example, in 2019 here in Pennsylvania, all the events had a mid-latitude cyclone, all the events had a front, all the events had a dew point greater than 65 and also a K index. And from their analysis, they can also do statistical work, maybe to change the threshold or to compute the standard deviation or whatnot. And then finally, we have some evaluation questions where we look at the big picture, and the evaluation questions, I believe, help the students get from the synthesis stage to actually writing the manuscript. My favorite, by the way, is the last question. What's one thing you learned about atmospheric behavior as a result of this project? Now, so at the end, the students do their presentations and we call a semester. We also, as practitioners, we wanted to assess what was the impact of this PBL on students. So last spring, we had 5 students volunteered, and we gave them an IRB approved study where we gave them a set of questions both before and after the PBL. And we have 2 major conclusions. The first is their affective attitudes, i.e. their comfort or their experience towards the PBL components. And you can see here that the open circles represent the mean class before, and the darkened circles represent the mean score after. So we were pretty encouraged that you can see there was general improvements from before and after. As you know, 5 is not really a lot of students, although we were able to get some statistically significant results, particularly when it came to the writing and the oral presentation. That actually seemed like it had the greatest impact on students. And then finally, we asked students, hey, did your knowledge increase? So we asked them to list the top atmospheric ingredients for severe weather before and also after, and you can see the results in this particular table. And the thing we want to emphasize is notice how after the PBL, students were able to not only list additional ingredients, but they were also able to list, there was more of a depth. So they were able to bring in some severe weather parameters like the total index. So in other words, we believe that their knowledge also increased, both in the breadth and also the depth of severe weather. All right, well, thank you so much for bearing with us the last 15 minutes or so. If you are a practitioner, we just hope that this is something that you consider. Obviously, it makes use of a wonderful website, online website, and during a pandemic, or if there happens to be a snow day, you can always use this without too much interruption. We believe this PBL provides the practitioner additional option to extend foundational knowledge, and in kind of in a fun way. I mean, severe weather is awesome. Students get to hone their weather forecasting skills, and of course, communication when it comes to the oral presentation. So thank you so much, and we hope you take just a thing or two from our presentation, and we wish you the best. Thank you.